right down here. So the pirol molecule, as you can see, 5 atoms in the ring. And if we take a look at the carbons in the ring, we can see that those carbons all have a double bond to them. Therefore, each of those carbons is sp2 hybridized, meaning each of the carbons has a free p orbital. So I can go ahead and draw a free p orbital on each of those 4 carbons like that. In terms of the nitrogen on the ring, I need to know the hybridization state of this nitrogen. So the best way to do that is to calculate the steric number. So we know the steric number is equal to the number of sigma bonds plus number of lone pairs of electrons. And so I can see that here is a sigma bond, here is a sigma bond, and here is a sigma bond. So 3 sigma bonds plus lone pairs of electrons. There's 1 lone pair of electrons on that nitrogen there. So the steric number should be equal to 4, which would imply an sp3 hybridization state for pirol. So we know that's not the case because pirol is an aromatic molecule, and sp3 hybridized nitrogen would mean no p orbitals at that nitrogen, which would violate the first criterion for this compound to be aromatic. And so there must be some way to get that nitrogen to be sp2 hybridized. And of course, we saw how to do that in the end of the last video. This lone pair of electrons on this nitrogen is actually not localized to this nitrogen. We can take this lone pair of electrons and move them in here so that lone pair of electrons can participate in resonance. So if those lone pairs of electrons move into there to form a pi bond, that would kick these electrons off onto this carbon. So the resonance structure will have nitrogen with a pi bond here now, and a lone pair of electrons on this carbon, which would give this carbon a -1 formal charge. We still have a pi bond over here like that. And this nitrogen now would have a +1 formal charge. Now when we analyze the hybridization state of this nitrogen, we can see that once again we're going for sigma bonds. So 1 sigma bond, 2 sigma bonds, 3 sigma bonds. So 3 sigma bonds. This time no lone pairs of electrons because that lone pair of electrons is now delocalized in resonance. And so 3 plus 0 is of course 3, meaning that this nitrogen is now sp2 hybridized. Since that nitrogen is sp2 hybridized, it has a free p orbital, so we can go ahead and draw the p orbital on that nitrogen. And so you could think about in terms of dot structure, right? So these two electrons over here, right? These 2 electrons are actually delocalized and participate in resonance. So that lone pair of electrons you could think about as occupying a p orbital here, and they're actually delocalized, right? So we have all these pi electrons delocalized throughout our ring. And so let's go ahead and check the criteria for aromaticity. So pirol does contain a ring of continuously overlapping p orbitals, and it does have 4n plus 2 pi electrons in that ring. So let's go ahead and highlight those, right? So we had these pi electrons, so that's 2, these pi electrons, so that's 4, and then these pi electrons here in magenta are actually delocalized in the ring. So that gives us 6 pi electrons. So if n is equal to 1, 4 times 1 plus 2 gives me 6 pi electrons. So pirol has 6 pi electrons and it also has a ring of continuously overlapping p orbitals, so we can say that it is aromatic. Let's go ahead and look at another molecule here. So similar